Thank you, Amarnath ji, and I think your opening remarks and also your introduction that was given is very apt to what we are talking. So, you having spent time in Lakshadweep and you've worked in different departments, which all of these departments are what connects the dots towards bringing us to net zero. So, I picked up Lakshadweep because I'm doing a complete project study on how we can make Lakshadweep completely green in terms of the entire energy needs. So when I say energy, I'm talking about electricity, fuel, the whole works. So you picked up a very interesting topic, sir, on the aviation fuel. And only yesterday I was in Norway and we were with some oil companies and we are doing some interesting work on sustainable aviation fuel. I believe the world consumes about 100 billion gallons of fuel, the aviation sector does. And the aviation body in the world, they are looking at least 10% coming from sustainable resources. And as we know that the airline industry is one of the toughest industry to decarbonize. So, if you have to change the airline industry to a hydrogen engine, it's going to take 10, 15 years and there are a lot of safety issues, concerns, etc., etc. So using the carbon capture and doing co-electrolysis, which I will, address in my presentation. But this, I think, even on India context, we are all talking hydrogen, and we all believe that hydrogen is the next holy grail, and it is going to solve our problems tomorrow morning. But that may not be the case. What you rightly pointed out, the city gas distribution network, which can take 20% hydrogen at least. A blending of hydrogen with this natural gas, making it cleaner, increasing the calorific value, and then using hydrogen as a dominant molecule to produce high-value alcohols or other oleofins like kerosene and methanol and also ammonia. So, these three are going to be the key factors to bring in this whole net zero world or decarbonized world. So, the more and more we are moving towards defossilization, these are the things that we would be requiring. And very proud to say that we pioneered this whole effort in India. It's been 14 years that I found my company H2E Power. And we are now owner of technology that can do the co-electrolysis process and also electrolysis process. We are making all of this in India, inspired by the Honorable Prime Minister's vision of Atmanirbhar Bharat. And we'll be setting up our first sustainable aviation fuel plant using co-electrolysis in Pune, where my headquarters is, in the next 8 to 10 months. So with your permission, sir, I will just go through my presentation. Of course, with the COP21, COP26 discussion happening. The biggest dilemma that we as a world are facing is how to save the planet. But if I look from an Indian context, if I have to worry about saving the planet, I will not save the nation, because we are a power-hungry nation, we are a developing nation, and we cannot shunt our growth just because we have to emit less carbon. So that's the big dilemma, that how do we grow and develop at the same time we also save the planet. And India in that context has the big potential to lead the entire process of decarbonization while not sacrificing the development and growth that the country is so hungry for. So we always talk about one sun, one nation, one grid. That is what our Honorable Prime Minister always says. I have taken the liberty to add another line to it, is one fuel. And that one fuel is hydrogen, the dominant molecule, which will take us to the realization of Swadeshi Urja for a Swavalambi Bharat. So, which in English means that unless you are self-reliant, unless you have energy made in India, you cannot be a self-reliant nation. So, energy transition, the way we are transiting and converging on energy, we all know how we use the energy, and the future is looking very bright with hydrogen becoming the dominant molecule, and then we produce a different kind of fuels from hydrogen. So the process has started in the 90s already, with the world looking at reducing emissions, and by 2050, countries in Europe, especially if you look at Germany or Norway, they're looking at defossilization by 2050, where I think in Germany they have mandated that 35% of the aviation fuel will come from the SAF route, that is Sustainable Aviation Fuel route, and about 70% of their energy needs will come from the hydrogen molecule. So, these are big steps that they have taken. And why hydrogen? I think all of us, distinguished speakers and also people in the panel, know why hydrogen is a good fuel. On the emission side, tailpipe, we get water. If you look at the end emission, and if you're able to generate hydrogen from green resources like the electrolysis process using solar, wind, hydro, and also the waste. This can become a completely carbon negative fuel. Of course, we have a challenge in transporting hydrogen, which is what the world is currently working on in terms of technologies on transportation, or even converting that into ammonia or methanol, which will make it easy to transport. So the whole idea, again, I am not so fixated on hydrogen as a subject. I am, as an individual, fixated on net zero, because unless we get to net zero, there is no future for us and also for the coming generations. So people always talk about battery electric vehicles and they being zero emission, but nobody talks about where the electricity for the battery electric vehicles is coming from. Most of it is coming from black coal or brown coal. So if you compare that with a Bharat 6 diesel or a Euro 6 diesel, the diesel vehicle is less polluting than the electric vehicle. So we have to look at that entire holistic approach where we decarbonize everything. We reach to net zero. There are technologies that I can even use diesel and cut down NOx, SOx, POX, CO and particulate matter emissions to zero. We have actually developed a solid oxide fuel cell system that is running on diesel, where the emissions are going down by almost 75 to 80% overall, including the CO2 emissions. So we have to look at also the tailpipe side and also the generation side. And hydrogen with CCS, represents that big opportunity to reach to net zero while not sacrificing on the energy requirements. And waste, as I mentioned earlier, is another very interesting subject. People in the world are not so keen on waste because they don't have so much waste. In India, we have a lot of waste, and that is one of our biggest problems. And converting waste into hydrogen, waste into e-fuels, not only gets us green fuel, but also solves the problem of waste, which is creating a lot of health issues amongst urban as well as rural population. The mosquitoes, we report COVID cases going down, but nobody reports dengue cases going up. So waste is a big problem, and that can be a big asset as far as India is concerned. We're talking about electrolysis. There are three prominent or dominant technologies. I'm just getting into a little technical thing on how we produce hydrogen. The alkaline electrolyzers, as we all know, in India in 1964, Bakaranangal Dam hosted the first alkaline electrolyzer, and which also is the cheapest and the most mature technology today. PEM electrolyzers are the emerging technology, and then is the solid oxide electrolyzers. All of them have their own space. It's not that one technology is the answer for everything. But with the solid oxide electrolyzers, it is capable of co-electrolysis and is highly efficient, almost 40% more efficient than alkaline or PEM. But again, it is high temperature and cannot do start-stop cycle. So each technology has their own advantages, disadvantages. But these are the three dominant technologies on electrolysis which are currently available in the world, and in the coming years we will have at least a few hundreds of megawatt of plant for all three technologies in India. My company is setting up a solid oxide electrolysis, stack manufacturing and alkaline electrolyzer manufacturing facility in Pune. So combined we will be about a gigawatt scale facility, which will be up and running by early 2023. Power to X is the biggest opportunity if you talk about hydrogen, because you cannot use hydrogen directly in one and every application. Taking carbon capture and then converting that into methane, converting that into methanol, converting it into kerosene, opens up a large array of applications for decarbonizing as well as immediate use. And using the Haber-Bosch process, capturing air and producing ammonia, is not only useful for the fertilizer industry in India, but ammonia can, sir, also become a fuel for generating electricity. So if you're looking at decentralized power generation, if you're looking at every home to become a power plant through your city gas distribution networks, in rural areas especially, ammonia can become a dominant fuel also for electricity generation. And this is one subject that we are working on, and something that the world is really looking at is the sustainable aviation fuel. So we are working on producing kerosene, which is J155 grade, which is aviation grade kerosene, and also ammonia to be used in marine. So the aviation and the marine industry, these are two industries which really need decarbonization, and using the electrolysis technology with carbon capture and producing either kerosene or ammonia, and then using that ammonia with fuel cells to drive the powertrain on the ships, and using the fuel directly in aeroplanes. One of the projects we did along with the Fraunhofer Institute in Germany, which is based in Dresden. Airbus has taken that fuel, and they actually did a sortie of about 2 hours using the kerosene. So it is something that is proven. It is not something that we are trying to reinvent the wheel or trying to, innovate something which has a long technology time. And in terms of technology, we are out of the valley of death, that proverbial valley of death, where a lot of companies fail, a lot of technologies fail. These technologies are proven at European level, at Japanese level, American levels, and now we are trying to indigenize these technologies to make sure that they work in India, and that they can be made in a very inexpensive manner, wherein India can not only use these technologies but can also become the manufacturing hub and export these technologies across borders, including exporting of fuel. So today we are a net importer of fuel. India imports almost $160 billion worth of energy. There can be a time, at least in our lifetime, I hope that we'll be able to export fuel. We can become a electro state where we become net exporters. Green ammonia, as I mentioned earlier, for the shipping industry and also for transportation and residential or electricity generation for industry, is a very potent form of carrying hydrogen. And ammonia is easy to carry as compared to hydrogen, and it also is a green fuel, so it has no carbon. And therefore, a lot of countries like Japan, who are 100% fixated on net zero, are trying to move to ammonia because that's easier as a fuel. The global energy scenario, I just put this slide for academic purposes, and our requirements are increasing while the reliance on fossils has to decrease. So, that's always a big problem with the world. And another problem with the world also is lack of resources. We use a lot of lithium and cobalt in batteries, though batteries are very clean and have higher power density. But we have limited resource of lithium, cobalt, and all of that is controlled by one country. So, almost 80-90% is controlled by China, and that creates a very interesting and a very scary proposition for the world. If you look at hydrogen technologies, most of these technologies can be made in India, or they can be locally made wherever you are. The components are locally available or can be locally developed. Like we have developed all the components and supply chain in India. We are going to have a product which is almost 98 or 99% made in India, which makes us more and more independent even on the supply side, not only on the end side. On the waste, this is a process that we've been also working on, gasification process. Indian Oil along with IISc is doing a lot of work on the gasification process to produce hydrogen. And this, in my opinion, will be the cheapest hydrogen. Even if I can, dare to say that we can go below $1 also, because as long as the waste is available. And I will take a break from hydrogen and get into business segments, which Amarnath ji also mentioned in terms of electricity to reach to industry, electricity to reach to villages. And the whole fuel cell and electrolyzer combination, or combination of different fuels with a fuel cell, can solve this problem for industries where we can provide combined heat and power solutions on a sustainable and an affordable basis, provide energy to agriculture. Nobody talks agriculture, but this is a very important subject, sir. We have 118 million cultivators in the country, and if every farm can become a factory, if every farmer can become energy independent, all of these farmers have a potential to become SMEs. Most of them today have a potential to hang themselves and commit suicide. But if they become energy independent, if they become prosperous, we will bring in a very different kind of energy revolution in this country. Again, coming to the well to wheel, I always talk about wheel to grave also. Technologies like fuel cell and battery combined. We have new battery chemistries coming in like salt battery. We have batteries like redox flow batteries, which can be used also in automotives. So on well to tank, tank to wheel, and wheel to grave, we have solutions that can work. And then coming to mini and micro grids, where small homes up to industries can get use of fuels like ammonia or hydrogen using fuel cells and producing energy. So this is just a snapshot on what potential India has if you just look at electrolysis or if you look at waste to hydrogen. And if all of this is monetized, I think the day that we will become an exporter will not be a pipe dream, but will become a reality of our world. And to end this, India, as we all know, is on the cusp of change. India is led by a very dynamic government which is trying to do things. We have somebody from the bureaucracy here, and we've seen magical things happen even at the bureaucratic level. This is India that we all dreamt of, and we as entrepreneurs are really fascinatingly enjoying this journey here to make in India and do things here in the country. And this is talking a little bit about H2E, my company. We've been inspired greatly by Kalam Saab and his vision for India. So our vision is 24/7 clean, green, affordable, and reliable energy for all, and that's what we are striving for, working with. And we are looking at bringing in a better world for us and the future generations to come. Unfortunately, I have to leave a little early, but if there are any questions, I would be more than happy to take them offline and contribute to that. Thank you very much for the patient listening and for this opportunity.